Hello, 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 statisticians. Okay, so let's look at the objective for this particular video. We're going to be talking about what statistics is, the nature of statistics, what a hypothesis test and what a significance test is. This is what statistics is all about. So here, we're going to be stating the null and alternative hypothesis for a significance test about the population. So let's go to our notes. Okay, now, statistics, the basic idea behind it is a procedure that allows us to test two competing claims, often against the population. So, water everywhere and not enough to drink. At least I don't like drinking it. Right here, 16.9 fluid ounces for the Costco bottle of water. So here, as I look at this idea, the claim is, the company says 16.9 fluid ounces. My claim is, I don't think so. That is the two competing claims. Here, another name for it, as you can see right here, and you're going to hear me kind of fluctuate back and forth. Significance test, hypothesis test. So we're given observations of data. So like me going to Costco and buying bottled water like I always do, and we have to make a decision between the two claims. When we do this, that is what's called the hypothesis. And the first step that we have to have is to make a claim or a statement. Now, my claim is I'm being cheated. I don't believe you guys. You say it's 16.9 fluid ounces. Bottles are feeling a little light for me. It's not true. They're fine. But let's say that that's my claim. Now, as I continue to look at this, okay, a hypothesis test in general is about, it comes up with two types of hypothesis, the null hypothesis and the alternative hypothesis. And as we look at the null hypothesis is what's referred to the HO. The alternative hypothesis is the HA. So as I use the example of the bottled water, here the Costco water, the HO is the manufacturer's claim in this case, that the manufacturer, which I'm referring to as the population, is saying that their bottled water is 16.9 fluid ounces. Well, I'm saying, I don't believe you. That bottle feels kind of light. So I'm saying here the HA is less than 16.9 fluid ounces. Please notice the two right here, and the only difference is the equal sign and the less than sign. I was about to say something incorrectly, so let me clarify this now. You never say less than or greater than or equal to. You never, ever, ever say that. Because if that's the case, that means, is it going to be less than or is it going to be equal to? So as we look at it here, the null hypothesis is always about equality. The alternative hypothesis is going to be less than. It can even be greater than, but let's see. So here, one thing we have to do is to make sure that the HO, which is your Greek, is going to equal something right there. For the basic one that we're talked about today, here is going to be your Greek symbol, which can be your mu. It could be your sigma. It can be your, well, this is not Greek, so it could be your proportion. So it can be a P, it can be the sigma, or it can be a mu. Why? Because it's always about the population. It's never about the sample. We're comparing our group to that of the population. So here, the Greek is going to go in here, the rho or the P, the sigma or the mu, okay? And here, this is going to equal whatever the value is as we look at this example right here. As I stated, the hypothesis is always about the population. So I said this, but it should be repeated over and over again. What is the reason of a significance test? To make a decision between two claims. That is the bottom line. And as I'm talking about the water, their claim is that there's nothing wrong with our bottles. They do contain 16.9 fluid ounces. My claim is, and then basically it's on people. It's time to prove it one way or the other. So as we're doing that, we have to think about how our claims can look. So first of all, our HO is always the status quo. It is always the manufacturer's claim. Our HA, my marker's terrible. My HA is that it can be the HA, it can be less than, it can be greater than. But remember, as I stated up here, it can never be less than or equal to or greater than or equal to. Now let's look at what it looks like. A one tail is exactly as it says, okay? The bottom line is these curves have two tails, one here, one there, one here, one there. But our thing is we're only going to look at one tail. And if it's less than, it's the lesser number, the smaller tail if you want to look at thinking about a number line. Over here, greater than, it is the greater tail. Two-sided, as we look at the idea of the two-sided, here, mu is going to be not equal to. Now, how would that claim sound? That means I come into the manufacturing plant and sound flaky and say to them, I don't know what the weight of the bottle is. I just know it's not equal to 16.9, which means I feel that they're a little light. Oh, in another situation, oh, I feel like they're a little heavy. Oh, I'm being inconsistent, I'm being a flaky female. But this is the thing, when it's not equal to, I'm looking at, it could be the lower side or it could be the upper side, okay? And in this particular situation, like I said, I'm saying, I don't know which one it is, but your company's cheating me. Okay, a little bit absurd, right? But especially in the scenario I just gave. So now let's jump to our questions. Please take a minute to read this. So as I look at this, we have hemoglobin and protein. Okay, people with less than 12 grams of hemoglobin per deciliter of blood are anemic. And public health wants to see what's happening for the Jordanian children in terms of their risk for anemia. Yes, I see I have a sample size of N of 50. Now, we're not worried about that yet. We just want to look at what our HO and our HA is. Our HO is that it seems like 12 is the cutoff. So if that's the cutoff, your HO is going to be, mu is going to be 12 grams per deciliter. So the mu is going to equal that amount. We're saying that that's the cutoff. And then we're saying if it's less than that, they are anemic. So here is our null hypothesis, and that is our alternative hypothesis. Now let's turn to the next page. Okay, please take a moment to read over this. Now, before I go on to number 4, I wanted to finish this off because it was incomplete. Because I've got my HO and my HA, which is my mu, remember it's all about the Greek, and as we're looking at this, what does mu truly represent? Well, in this case, it's the true mean number of, or amount, I should say, I don't like that, amount of hemoglobin in the Jordanian children. Tried to cross an L. So sad, so sad. Okay, so let's now go to problem number 4. Okay, so here we have a Gallup poll reports and reveals 72%. Okay, of teens say they seldom or never argue with their friends. So we have this information right here. So Yvonne wonders if this is true. So our HO, which is our null hypothesis, is that here we have the proportion is going to equal to 72%. That is our HO, because that is the national poll. And then she's wondering about the results, if it holds true at her school. Now, she didn't say whether it was less or whether it was greater. She's just saying, I'm wondering if it's going to be different. And there is your less than, excuse me, wrong, your not equal to. Because, let's make a note, it did not state less than, it did not state greater than. She's just trying to see if it is different. Now here, we've got to make sure to define what P is, where P is the true proportion of teens in her class who rarely or never argue with a friend. Okay, now let's do our last problem. Please pause and read it. Okay, so as we paraphrase this, we're talking about ski jumpers and their distance. Okay, and the organization, okay, we look for a positive landing allows the difference in the distance of the athletes. So right here, look, we are given the standard deviation. So as we see that here, our HO is that this is we know it's the population information because it's a sigma. So the HO is that we're saying, okay, this is the standard, that it is equal to 10. Okay, and now they're saying the alternative hypothesis is the organizers are underestimating the variation. Okay, so that means they're saying that if they're underestimating, they're expecting it to be greater than the amount that they said. So underestimating, greater. Now, we've done the HO and the HA, so now let's look at this part. Okay, where sigma, what does sigma represent here? It represents the true standard deviation of the distance jumped by the ski jumpers. So, that is the end of 9.1, at least the first part of it. Now go ahead and do your homework, guys. Bye, 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 bye. Okay, can't sing, I know it. See you guys later. Bye-bye.